A difficult and boring way to learn Ohm's law is through algebra operations that not everybody enjoys. There is a much simpler way, by using a water analogy, that is, using the example of a water pump. There are three factors involved in Ohm's law: pressure, speaking of voltage; opposition, speaking of resistance; flow, speaking of electric current. In other words, Ohm's law states that the higher the pressure applied across a given opposition, the greater the flow will be. On the other hand, if pressure remains constant and we decrease the opposition, the flow will also be greater. In simple terms, the more the pressure, the greater the flow, and the more the opposition, the smaller the flow. Now let's look at an example of a water pump, a pipe and a valve. We start with the valve open all the way. We start the pump and water flows freely, as indicated by the thick arrows. This is similar to a medium voltage applied across a very low value resistor. The current will be quite intense. Now, as the second part of the experiment, we close the valve halfway. We start the pump again and we will know that the water flow will be much smaller since the opposition got bigger, as if the pipe were thinner now. This is similar to a medium voltage applied to a higher value resistance. The flow will be greatly reduced. Now we shut the valve completely. We run the pump and we will know that no water flows through the pipe. This is similar to having an electric circuit in which the cable has been cut and the electrical current cannot flow. Now let's suppose we increase the pump speed. Also, we open the valve all the way again. Now the water flow will be greater than the first time, since the pressure has increased. This is similar to an electric circuit in which two batteries are used in order to get a greater flow of electric current. If we close the valve halfway, as we did previously in the second part of the experiment, the current will be greater than the first time since, although we partially closed the valve, this time the pressure is greater since the pump is turning faster. Finally, if we close the valve completely, no water will flow, even at a higher pump speed, because the opposition is too large. Again, this is equivalent to cutting the wire in an electric circuit, and the current will stay at zero even if we apply twice the voltage by using two batteries. In a formula such as Ohm's law, there are three values involved: voltage, resistance, and current. By means of transpositions of the letters that make up the formula, we can determine what values to calculate. However, there is a much simpler way, without any knowledge of algebra whatsoever. If we write Ohm's law like this, we just have to cover with our hand the value we want to find, and whatever remains visible will be the operation we must carry out. For example, if we want to find the voltage when we already know the resistance and the current, we put our hand over the letter V, which stands for voltage, and multiply current by resistance. If we want to find the current when we already know the voltage and resistance, we now cover the letter C for current and divide voltage by resistance. If we want to find the resistance when we already know the voltage and the current, we put our hand over the letter R for resistance and divide voltage by current. We must keep in mind that whenever the resulting values are expressed in decimal fractions, we are getting milliamps, millivolts, or fractions of an ohm, depending on what we are trying to find. I hope this video has been useful for you. Thanks for watching, and please subscribe to my channel.